In this video, I'm going to demonstrate how to create a relation between two elements or tables within our XML schema designer. You might ask yourself the question, well, why would I even want to create a relationship between these two elements that I have here? Well, keep in mind that a schema is simply a definition of how an XML document should look. In the case of .NET, the schema is also a definition of how a data set should look. And within a data set, you can basically access the relationships between two data tables within the data set through a data relation object. It allows you to say, okay, for this customer, give me all of his orders, and the data set can manage that on the client side and not have to refer back to SQL Server or whatever the original data source was. That might not make sense in all applications, but that's basically the gist of it, that you're able to navigate from one record to all of its associated records from another data table. So there's a very good purpose for having this functionality in there. We just forces us to think less in terms of a typical XML document and more in terms of a relational database. But that's okay, because it does have a lot of purpose and value. So what we're going to do is to create a data relation, I'm going to go to the toolbox and I'm going to drag and drop a relation onto my customer table. And when I do, the Edit Relation dialog box appears. Unfortunately, it's too big to see the entire thing. Trust me, at the very bottom of the data relation, there's simply an OK, Cancel, and a Help button. The first thing that you can do is name your customer relation. Notice that it gives you a default name that we will change in just a moment. Basically, you create a relation between two tables. The parent table will be customer, and you'll notice that the customer key is already selected. And then we need to choose a child element, so we'll choose the order table. So kind of think of these things in columns. Let me draw a picture here that this all kind of goes together, where you see the parent element and the key field, and then also the child element and the foreign key fields. So think of it in terms of within the order table, what is the foreign key field? And so we'll make a selection right now that it's the customer ID. Okay, now notice when we did that our name has changed from customer to customer order. Now, the only reason that this is important is because when you do convert this into a strongly typed data set, you will be able to refer to the data relation by name or by index. So index is not a very friendly way to self-document your programming. Therefore, you'll want to name this something meaningful. And so you can access it if you need to through code. Also, let me point out that if you didn't have a key defined up to this point, you could simply select the New button here, and it would pop up in the Edit Key dialog, and we could build one just like we did in the previous video. But we're not going to do that this time. So now that we've made an association between the customer table and the field customer ID with the order table and the customer ID is the foreign key field, now that we've made that relationship, we need to set some properties that will be meaningful whenever we create a data set from this XSD. So we talked just a moment ago about the value of the data relation object within a data set and how you could navigate between records. For example, if you had a customer, you could find all the orders for that given customer using the data relation object. It would allow you to kind of cross-navigate between different data tables within your data set. Well, you can turn that functionality off by selecting this option here, Create Foreign Key Constraint Only. Basically, the benefit of that is there's a lot of code that goes along with enabling that functionality of that navigation between the two relationships and be able to find records. But maybe you don't need that. Maybe all you need is just to enforce a foreign key constraint. So for example, if there's a new order that's added, it has to be associated with a customer. But that's the only reason that you want that that relationship between those two tables to even exist. If that's the case, then you'll definitely want to select this because you'll get a little bit more efficient data set generated because it'll have fewer methods in it that typically would control the other type of navigation. And then finally, at the very bottom, and I'm going to pull this up just a little bit so you can see it a little bit better. The bottom of the Edit Relation dialog, you'll notice that there are these 3 drop-down list boxes. And this gets us into the topic of referential integrity. Perhaps you're already familiar with this topic, but for those who aren't, referential integrity is when you have this relationship, let's say, between the customer table and the order table. Now imagine what would happen if in the database or in the data set, if you were to delete one of the customer records. There would be orphaned order records potentially associated with the former customer record, but it's now gone, so you may never see those order records again if there's any of select statements that kind of do this join between those two tables or exercise the relationship between the two tables. So that would be a very bad thing if we were to delete your customer record but still leave all of the adjoining order records into the data set or the database. What should be the proper course of event? Well, that kind of depends on your application. Some people would prefer what are called cascading deletes or updates. So for example, if you were to do a deletion on a customer record, then you want it to delete all of its related rows in the order table as well. Maybe you would prefer to go ahead and leave the order records in the order table, or however you want to set the customer ID equals to null, or you want to set it to some default value if it was a date timestamp, or maybe you just don't want any action taken whatsoever. Maybe you have those rules already built in to your data provider and you don't want to enforce that on the client. Whatever the case might be, you have the ability for each of the different type of updating or deleting operations within your data set to kind of define how you want it to go. And that's what these are for. First of all, let's take a look at the update rule. When we drop down the list box, and I'm going to need to pull this up just a little bit more so you can see the whole drop down. In the update rule, you can either select none. That means if there is an update in the order, or I'm sorry, if there's an update in the customer record, you should do nothing to the order records that are associated with it, or you should cascade all the changes. So for example, if the customer ID has changed, then you should make a change also in all the order records that are associated with that customer. Or you should set all the records in the order table, the customer ID equal to null, or you should set them to some default value that's already been defined within your schema or within the database. And so the same thing is kind of true with the delete rule. Basically, if a record in the customer table is deleted, you shouldn't do anything, or you should cascade the deletes to delete all of the order records as well, or set all of the customer ID columns equal to null for those order records that are associated with the customer, or set them to some default value. Finally, we see the accept or reject rule right here. This is basically employed whenever there's a data collision when trying to update data that's out of sync. For example, if you were to retrieve data from a database and make changes to the data set on the client, and then need to take all the changes that were made and save them back into the original data source. What if there's collisions? What if somebody deleted or updated records out from under you while you had the data on the client? Well, in those situations, you need to kind of make a decision about what you're going to do, and you can handle those situations programmatically. We'll talk about that in the ADO.net series of lessons, and I haven't covered that just yet. But basically, you can either select to do nothing or to cascade the updates or deletes in those cases. In future videos, I'm going to demonstrate how all these rules work. But for right now, what I'd like to do is go ahead and select OK to the creation of the relationship. And notice when I do that, that it creates this little line between these two tables. And when I hover my mouse cursor over it, it refers to our relationship as a key ref. It even gives us a little handle to hold on to, and we can drag this around and move it around as we please. I can also right-click this and modify it in any way. For example, I can select Edit Relation, and it'll pop up the Edit Relation dialog again. I'm going to hit Cancel. We can also view the XML source and auto-arrange these. So let's do that. Let's just view the XML source, which simply did this for us. Okay. So let's take a look at what was created for us. We notice that there's a key ref element generated within our XSD, and it's named customer order. And notice that as the refer argument, it passes in the key that we created from the previous video, and it notes the field that is used to associate those tables together. Now, what if we wanted to delete this relationship? All we would need to do is select it, and at the very bottom, you can't see this, but I'm going to select Delete. Or you could simply have selected the Delete key on your keyboard once the data relation was selected. Now, since I didn't cover this in the previous video, you can do pretty much the same thing for the key. I can select the key, and I can delete it as well. Or I will be able to edit it if I hit it just in the right spot. There we go, Edit key. And I could change it if I wanted to, or I can select Delete key, and it's gone. So this explains the creation of keys and relations within the XML Schema Designer. Again, the value is in so much that we can create data sets from our schemas. We can also create relations, data relation objects, to relate essentially these two data tables that are displayed as elements within our schema. And we can manipulate data through the use of there, and it gives us some additional functionality. We'll cover that in a future video. Thank you very much.